Steag. I'll introduce them one by one.
B.P.Rao, Managing Director, Steag Energy Services India. From 1978 to 2015, he worked in BHEL and retired as Chairman and Managing Director. He has been member of boards for many companies and has presented several papers and delivered talks at international conferences. He was also part of a high-powered business delegation from India, accompanying the President and Prime Minister to a large number of countries: Australia, China, Germany, USA, South Korea, Belarus, France, Kazakhstan, Japan, etc. He is a graduate in mechanical engineering and postgraduate in industrial engineering. Joining him will be Dr. Tomasz Kaminski, Project Director, System Technologies Division, Steag Energy Services, Germany. He has 34 years' experience in monitoring, simulation, and optimization of thermal power plants. His professional experience in this field includes development of software systems for optimized soot blowing and for lifetime monitoring of boiler and piping components, commissioning of plant monitoring and optimization systems in several countries, project management for over 70 installations of online monitoring and optimization systems in India from 2003 until now, business development of international corporations. He received a PhD in design methods of fault-tolerant systems from Warsaw Technical University. Both of them, please welcome them on stage.
Thank you. Well, good afternoon, ladies and gentlemen. Audible? Yeah. Well, we are here to present really an actual, rather we are driving down deep into the application of it, the digital transformation. Morning you have heard about NTPC laying down a map for their own plans for digital transformation in their power plants. We are a company dealing with the power plants, providing service to all the power plants. And you also heard, you have been probably aware that India is going through a revolution in power plants, that the conventional power is getting replaced with renewable power slowly. And we have huge targets, 175,000 gigawatts by 2022, and that is further getting added by another 100 gigawatts by 2027. These are the mega plants what we have. And most of it is happening, as you all know. Renewables are coming in a big way. So therefore, this is going to disrupt the existing power system, because renewables behave in a different way, and the conventional power plants have certain characteristics. So I'm not going to deal with it in more detail. But therefore, you need to have systems to deal with this merging of these two and see that still the power plants perform in the manner in which they are designed for, and at the same time giving the maximum efficiency. So that is the topic of this. That is the automatic process control, ensuring flexibilization in power plants. That is the topic which we are going to discuss. And before that, I will talk a little bit about the company. And of course, Dr. Kaminski is going to talk about the actual application, who is a development engineer in that particular system. And the first one, if you look at, this is of course the Steag company. Is a global company. In fact, the top left corner shows the Steag building in Germany, Essen, Germany. Now, Steag is owned by a number of municipalities in Germany. In fact, it is an 80-year-old company. And Steag Energy Services is the one which they have set up as a 100% owned subsidiary, providing services to set up the power plants for Steag. In fact, today, Steag owns roughly about 10 gigawatts, and Steag Energy Services gives services to 100 gigawatts of plants all over the world. Steag Energy Services India started sometime in 2001. We're almost about 17 years old already in this country. This is also another 100% owned company of Steag Energy Services Germany. We are a global company. The headquarters at Germany, Essen, Germany, with a number of setups in South Africa. We have US, we have a setup in Spain, we have a setup in Turkey. And India, of course, is the second biggest after Germany, dealing with not only India, but also Southeast Asia and the SAARC countries. Yeah, the same thing. This is important for us. Why we are unique? What we call as triad. We have a platform, and the platform is supported by 3 legs. The first leg is the energy technologies. This is a group which does the entire engineering work, engineering technologies in fact. The project engineering, pre-feasibility engineering, feasibility reports, project engineering, detailed engineering, and for all the power plants, the services are provided by this group. And also into newer systems like emission control systems, flexibilization systems, this group is providing the service. The second group is the O&M services group, which of course is the largest revenue earner for the entire company. We operate plants roughly about 100 gigawatts all over the world, and combine both engineering technologies and the plant services, you can call them as the OT, as the other speakers have been talking of, OT. That is where the process knowledge, is with them. And the third group is the IT-based process optimization. So that is what the group, takes the advantage of this, the so-called domain knowledge from these two, and converts them into systems which can deliver efficiency. All are in digital transformation, in the field of digital transformation, supplying systems like PADO, energy efficiency systems. Epsilon is another product of Steag, which is driving towards efficiency in management of power plants. We have other software packages looking at the cement industry with a Povitech package, where we also again look at the efficiency of the kiln, and similar such software applications. One of that is the APC, the automatic process control. This is something which is evolving, but the advantage here is that, as you know, Germany is the country first in the world to implement the integration of renewables. In fact, they first started implementing renewables in a big way, followed by Spain. Then the world, took up the renewables as a big revolution. So Germany went through a number of transformations, what we are now going through. So the advantage of the Steag is, therefore, Steag has done this work, and we are trying to get that to India. That is in India itself, we are operating plants about 6,000 megawatts. And this is a complete full-scale O&M, operation and maintenance, and we accept key performance indicators as our targets for achieving the whatever payments we need to receive. We accept the payments against them. So that's the kind of challenges we take. So this is something, the various groups under the Steag Energy Services. Well, in Germany, we have this nuclear technologies group where the nuclear is being dismantled. In fact, the service offered for dismantling the nuclear power plants. So Germany is going through, after the Fukushima accident, Germany has decided as a policy to dismantle all the nuclear power plants. So there is a big service being offered by this group. In fact, you need to dismantle also very carefully and dispose them off. We have also asset-light projects where we take up mini EPC projects, and also small investments also we take into those projects. So wind and solar is also our focus area for giving the operation maintenance services. We have projects in Turkey, we have projects in Brazil. We are providing active services. We are also integrating, these days, the weather forecasting sites, weather forecasting into our, say, for example, wind operation maintenance plants. So we can predict how wind is going to change. Therefore, what is the kind of schedule you are going to announce to the grid operator. So you can, these systems will assist you in providing such information. So this is the presence in India. We have plants at Visakhapatnam, which is the Hinduja plant, and we have plant at another major plant at Singareni, which is 2 into 600 megawatts, and we have all the Gujarat. Most of the gas turbine based plants are in Gujarat. We operate all kinds of plants, whether it is coal or thermal or even hydro. We are trying to get into now. Vedanta is a big, is a main customer for us. We are operating the Talwandi plant for about 2,000 megawatts, 3 into 660 megawatts. And in fact, all these plants are delivering the best performance. In fact, Singareni plant is almost coming as the at number 5 in the best performing power plants in the country, which the Ministry of Power gives a ranking of this. We have offices in Noida at Delhi, and we have also regional offices. We have various sites. So we have about 1,500 people in India, and we have delivered more than about, in fact, we execute many of these IT digital transformation projects through also one of the partners of BHEL. We execute through them. The BHEL Electronics Division at Bangalore is our partner. And we have supplied about 120 PADO systems, what we call as performance analysis and design optimization systems for the power plants. We have a simulator group, and we as an organization in India also identified and recognized by Government of India for training people in power. We take almost about 20 to 30 graduate engineers every year, and also similar number for diploma holders, and give them a certificate at the end of 1 year course, and they are accepted. So this is something which we carry out. Now, without going through many of the details, now I'll hand over to Dr. Kaminski to talk about the APC portion.
Thank you very much, Mr. Rao, for the
Please carry on.
Of our presentation. So I will present you some solutions for flexibilization of power plants, which Steag provide, and services which we provide for flexibilization. First, why power plant flexibilization? In this diagram, you see the two situations. One situation when renewables, that is this green area, provide very low total power generation. And the other situation is when these renewables provide much more energy. And there are two extreme cases which I give always as example. On the 1st January 2018, the whole demand of Germany was covered by renewables, was covered practically only, because it's winter, only by wind. And this example is always given by advocates of renewables who say, look, now we can provide almost the all demand by renewables. Why we should run the thermal power plants, especially lignite power plants? For instance, the Green Party puts frequently demand switch off 20 lignite power plants in Germany, which lead, of course, to the big gap on the power generation. Why gap? Because there were 3 days in November 2017 where renewables were not available at all. So you have now the situation to this two extreme situation, no renewables at all. Renewables can cover almost the whole demand. And this, of course, leads to the very difficult situation of the operator of the thermal power plants, because they can face these challenges and to find the solution how they can sustain in the situation when the planning of the operation is very difficult, and the operation and keeping, for instance, especially the manpower in the power plants is very costly. So there are two things. First, technical problems with running these power plants. And second, of course, economical. If we go now to the next slide, we see here some examples. What was the demand of the operation hours per year in the past, and what is the demand now? These figures speak for themselves. The power plants do not have enough schedule. That is one problem. The other problem, the prices for the energy are very volatile. That means the producer gets for the 1 megawatt power between 12 euros and 60 euros. So it's a big big difference of the prices. On the other hand, consumers, private consumers like me, face a situation that energy becomes more and more costly in Germany. In the last 10 years, cost of the energy for the private consumers increased by 50%. So all these economic factors cause very high pressure of the thermal power plant operators, and they try to find the solutions how we can deal with such situation that we sustain, that we make some money, because all these private companies work for profit. There are two. Now, when we take a look, come to the technical part of the more technical part of the presentation. If you take a look at the scheme of the power plant with the boiler, HP heaters, low preheaters, condenser, turbines, and flue gas part, there are a lot of areas which are affected by the less demand of the power, because this less demand is, there are practically two factors. One factor, the power plant run in the lower load. The operators try to keep the power plant in lower load because switching off, shut down the power plant and start up is very costly because of the additional fuel, supportive fuel, which we have to use. And the other thing is the power plant should react very fast to the changing demand because of the renewables. Wind comes suddenly, sun comes. The prediction of these changes of renewables are better and better, but nevertheless this change of the demand is very rapid. So we have to react very fast. And there are some areas in the plant which have been addressed. How to improve the ramping of the plant, how to run the plant from the lower load to the high load fast, and what are the challenges if I decrease the load, the operational load much below the current situation. And in this screen, this area shown. We have to consider circulation, especially for one through boiler. Circulation control, we have to take a look especially at the flame stability, flue gas temperatures. In all power plants, we have the Denox devices, we have the FGDs, especially Denox requires a special, the pretty small window for the temperatures. If we go with the load down and the temperature will go below the specific point, we'll have the problems with air preheaters. And one of the most critical area is the flame stability, which affects the safety of the operation. And if we want to now carry out the flexibilization measures, we have to take a look at all these elements. Now we come to the, I would like to come to the temperature control and the ramp rate improvement. As I said, because of the changing demand, the fast response by the thermal power plant to the load changes is very crucial from the economical point of view of the operators. If they are able to give the fast response, they will earn more money. So there's a lot of ideas and a lot of effort put to improve the ramping of the power plants. And one of the examples how it can be done is shown in this screen. We can implement the special, practically special computer, special industrial computer in the plant, which will give the biases for the controllers, which will enable much faster ramping than the standardized ramping given by the boiler producer. How it is done? in this software, we have the model which predicts temperature differences in the highly loaded component. The fast ramping of the operation causes high temperature differences in the thick wall components. And this high temperature differences cause higher fatigue. And one of the methods, of course, is to put the constant limits and telling if the temperature difference increase by factor X, then the firing rate will be slowed down. This method is not very practical from this, or doesn't give the best solutions from this simple reason that we don't use all possible margins which we have for running the unit as fast as possible. And this software has a model which predicts fatigue depending on the current rate of fuel. So if I can do this, I can make in the predictive mode control of the unit, so the all margins will be used in the optimum way. Interesting fact, when I talk about this device and this approach, is that the theoretical base for this was developed 30 years ago. So pretty long ago, we developed the model which can calculate temperature differences based only on the rate of the one temperature. But we use this model practically only for the monitoring. Now, because of the flexibilization, there's a demand for the very fast and effective control of the units. And there's now the new field for applying this model and applying this software for improving flexible operation of the plant. The other possibility to give the fast response for the changing demand is to use the internal storage which we have in the power plant. And there are here some examples which storage is already mentioned at the beginning. We can use, of course, the feed water tank. We can use the low pressure heaters, high pressure heaters. We can use, of course, the throttling of the main steam. And we can use, of course, the capacity of the mills. And every of this storage has the different practically features in respect to the time, responding time, and the time how long I can use this storage for address the problem with the changing demand. When we talk about the reduction of minimum load, we should analyze subordinate controls like live steam temperature control, fuel control, feed water control. We have to make the individual analysis, adaptation, optimization of each control to the demand, and make a recommendation, for instance, for the exchange of the sensors. In the German power plants, we have the flame detectors. For every burner, we have the individual flame detectors. In some Indian power plants, we have so-called zonal detectors. And when we want to reduce the load, we have to take care especially of these flame detectors to ensure that the operation will be safety. And we can, of course, we have to elaborate the concept of the controls, make the testing, and only after the very extensive testing we can ensure that the unit can run with a real low load. If we want to minimize the load, we have to, especially by one-through boilers, we have to take a look whether the boiler furnace will operate in the stable way. we have to take a look at the live and reheat steam temperature, take care whether the turbine ventilation will not happen. About the flame stability, I already talked. And we have to take a look at the all interlocks, which prevent that the boiler can be run at the minimum defined load. So, if we take now look at the next slide, we see here's the potential. What is the potential of the minimize the load? So, when you, for instance, take a look at the unit, the second unit, we minimize the load from the almost 37% to 20%, and in the other cases, we minimize the minimum load even to 10%. We ensure the boiler can operate only with 1 mil in the stable way. On the other hand, we have the information from the operators of the lignite power plants that such big reduction in some power plants were not possible, and they were put a lot of effort to reduce the load, minimum load only by 10%. So these figures are from, especially from our power plants, and we achieved on the minimizing the load real good result. Our services for higher flexibilization in your power plant, we can divide in the 3 groups. We can talk about the technical consultancy services. When we can carry out the comprehensive data assessment and evaluation by our expert. We have experience of identifying the process limitation. Every power plant has to be examined individually. There's a lot of differences between the plants. And we have the comprehensive in-house database. So we can take the experience from the past. Then the other group, we can give the recommendation of flexibilization power plants, not only by comprehensive technical support involving some red flag list, what should be done and what we should be, which limit shouldn't be exceeded, but we give you the very high accuracy economic estimation, cost estimation. What will be the benefit of the flexibilization? Because we know in all technical solutions which we provide, we have to always take a look what are the monetary benefits for the customer by the solution which we recommend. And second, the third group, we can implement these recommended measures, and we can, of course, cover this all 3 areas by our experience, by our experts. There's some other view of the services or devices which we provide. We call this Steag toolkit, and we have the booth in the exhibition, and if you want to get some more information about our tools, then please go to our booth. But coming back to this presentation, we have the consultancy services. When we provide retrofitting, we can provide enhancement of the underlying control loop and improve utilization of the system by inherent storage capabilities. And we apply advanced process control. One example I show you in the previous screen, but we have some bunch of the other tools, like we have the predictive analytics. We have the system for the combustion optimization, which is based on the APC models as well. We use the neural networks. And we carry out at the moment our sample project with the big data for the anomaly detection. That is a very interesting approach as well. You take all the measurements for the power plant without analyzing the relationship between the measurements. You put into the neural network, you learn the neural network with, for instance, 2-3 years data. And then if you apply this neural network to the current data, the neural network gives you the information where you have the anomalies. And that is a big advantage of the system, that you don't need any big investment to configure the system. You have to just provide the measurements of the input of the system, and you get the information about the anomalies. And we implement, of course, lifetime monitoring systems which are part of these flexibilization measures. I show you one PC with the model for the control of the process to use all margins for the flexibilization. But on the other hand, we have the monitoring system for lifetime. That system collect all data and calculate current consumption of the lifetime. So all economic decisions can be based on the technical information, how much highly loaded component has been used and how much lifetime consumption was used till now. And of course, we can make adjustment of all operational procedures, and we build, of course, higher awareness of the operators. And in the presentation which will be available, we make the overview of the selected references. And the references, we show some references from Germany. When we implement this APC, we show some references from one reference from Turkey, one reference from Chile, when we only provided services without implementing any solutions. So now I would say it's a time for flexibilization by Steag Energy Services. Thank you very much for your attention, and I invite you once again to our booth. Thank you.
Well, just as a final word, it's not possible for Dr. Kaminski to cover the entire system concept in this. So we invite you to the booth and where engineers are available to come and explain more about this APC. System for flexibilization. Well, I will be failing in my duty if I don't thank ARC. Mr. Ganapathy has been the force behind it, I know, right from the beginning. And we have been continuously associated with ARC right from its inception, probably, without miss. And he is doing a good job in India, particularly, bringing this particular community together and trying to focus everybody's attention on this. Thank you so much. Thank you for the continuous monitoring.
Thank you.